Here's an example of an equation that kind of breaks down under our normal processes. We see that the equation does have an x in the exponent position, which would suggest that it's exponential, and normally with exponential equations we convert to logarithms in order to gain access to that variable in the exponent. But when we do that, we write down the word log, we have our base is e, the argument then becomes negative x like this, and what we're equal to is the exponent, which is here. So a minute ago we had a problem because our variable was trapped in the exponent position. We converted it to logs in order to gain access to that exponent, but then it ended up getting trapped in the argument of the logarithm. So when we are in exponential form, it's trapped in the exponent. When we convert it to logs, it's now trapped in the argument. And really, no matter what we do here, we're not going to be able to get that x into a position where we can isolate it and solve for it. So what we can do in a case like this is what the directions suggest, is that we can solve for x by using a graphing utility. And what that means is we're essentially going to take the left-hand side and plug that into my y1 variable. We're going to let that be y1, and then the right hand side we're going to plug that into y2, and then find the x value that causes the two sides to be equal to each other. So here we go. We're going to plug the left hand side in. We'll let y1 be equal to e raised to the x power, and then the right hand side goes into y2, so that's negative x, and then we're going to graph these two sides. So we go over to the graph and we see that our two equations are intersecting right here. So in order to find what the x value that causes the two sides to be the same, essentially we're looking for the one x value causing the same y values, which means that that's the intersection point. So the function on our calculator that does this is under the calculate menu, and in order to access that we have to hit the second button and then calculate, so that we can come into here and then select the intersect function. So second calculate intersect, and I'm just going to hit number 5 in order to be able to get to the intersection. Now I can see that my cursor is on the first curve. I also can see that it's on the function that is in y1. So that is the first curve of the intersection that I'm interested in. I tell my calculator yes by hitting enter, and then it automatically jumps to the other function that's in y2. If this were not correct, I could go up and down to change the function that my cursor is on, but this is the other function that I'm interested in finding the intersection between, so I'm just going to tell it enter to say yes again, and then I'm going to move my cursor towards my guess point. It's possible that I could have two functions with more than one intersection, so I do need to move it to where closer to the point that I'm interested in. And now it says this, that the intersection is negative 0.567 and y is positive 0.567. So which one of these values is the answer? Well, again, we're looking for the solution to x. So this is the x value that causes the y values to be the same. So the solution to this equation is the x value, negative 0.567. So let's round that to 3 decimals, and we'll do this to indicate that it's an approximation. So it's negative 0.567, and this is the solution to our equation. We had to use the calculator to find this answer.